Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome you all to the third part of this series, right? And let's just dive deep into it. Just to save time, I already wrote the question, and that is Amanda picks up, or Amanda, how may ever you want to pronounce it. Amanda picks up two balls from the bag, one after the other with replacement, right? We learned about all that in the previous lecture. And I made a simple bag over here, right? I was trying to choose brown as a color for the bag, but the orange just came up, so I just kind of chose it. So you've got four green balls inside of it, and you've got three red balls inside of it. Okay? Now look, the events we have over here is event A is she picks up a red ball. Event B is that she picks up a green ball, right? Now what is this? That is what I want to talk about before I move on to anything else, okay? So now look, wait, let me write two, three over here. No mind. Now look. So remember we learned about and this thing is actually and. So the examiner, if you ever see this between the names or the symbols for two events, it's just asking for an and between two of the, two of the events, right? So this thing, this upside down U is just called intersection, right? I don't want to dive into the details, even though I can. It's more like the sets and stuff. If you've learned about sets in O levels, you would have known that what an intersection actually is, but I don't really think it's worth wasting time on right now. Okay, so this is just what intersection actually is. They're just asking you to find the probability of both of the events occurring at the same time. Like she is picking up a red ball and a green ball, right? It's just A and B. This is how you should read it. You should know how you're going to read it, right? It's just probability of A of A and B. See that? This is how you read it, okay? So obviously we learned how we're going to solve these, right? So every time two events are connected to each other by any kind of operator, we're first going to find the probabilities of the individual events, right? I mean, obviously you can do it in one step as well. However, I mean, just because we're beginning, I would rather do it in steps. So the probability of A is yes, the probability of A is she picks up a red ball. Now look, we know she's picking up two balls. So maybe it's going to be, um, yes, maybe it's going to be first red, then green, or it's going to be green, then red. I'm sorry, wait. I'm sorry. I mean, that was doing it all in one step. The probability for event A is she picks up a red ball, right? And that would be, in this case, she picks up a red ball. Yes. No. You know what? Let me tell you one thing. You guys are not kids anymore, honestly. Solving or finding the probability of the individual events and then applying the operator on them is a good thing. But in the exam, I don't really think you're going to have way too much time. I would rather not misguide you, okay? So I think now that we have learned about all this, it would be way better if you're just going to do it at once, right? Like literally just in one step. So regardless, I mean, instead of doing it one by one, all of the events, let's just do it all in one go, right? Probability of A intersection B is going to be A and B, both of the events occurring at the same time, right? So we just want to find the probability that she picks up a red ball as well as a green ball. What are the two scenarios in which, or what are, how many scenarios even are there wherein these conditions are going to be true? Okay. You want her to pick a red ball and you also want her to pick up a green ball. She might pick up a red ball once and then a green ball, or she's going to pick up a green ball and a red ball. Now look, I'm sorry. No. Both of these scenarios do what? Both of them satisfy A intersection B. In the first scenario, you've got a red ball and you've got a green ball, and the same thing applies to the second scenario that we have written over here, right? How do you, yes, there we go. Now, look, how are we going to solve this? You know what? It's easy. And yep, one thing, it's with replacement. So you don't really have to worry about the denominator being, changed. And you know what? Without replacement doesn't mean the denominator is going to be the only one changing, right? If you're going to pick up the same balls one after the other, even the denominator is going to change, right? I mean, these are the kinds of things, the kind of nuances I would rather call it, the subtleties that you might have to use common sense for. And honestly, I'm not saying that you would have to use common sense in the exam. You would have practiced quite a lot of past papers, right, before you sit the exam. So, when you're what did I just do? Sorry. Yes. So, yeah, you inside the exam. Sorry, before the exam, when you're attempting past papers, these nuances are something that you're just going to learn about anyway, right? Like through practice, rather than me having to tell you on a board. Okay? No, no. So the probability for both of these is what? The probability that she picks up a red ball is going to be how many red balls are there? Three, right? So it's going to be 3/7. Why? Because there are seven balls in total, right? Multiplied by the probability for the green ball, that would be 4/7. It's not six. Why? Because she put it back in there. Okay, and then you add both of these, and it's just going to be 4/7 this time, multiplied by 3/7. And you get yourself the answer. Again, I'm lazy. I don't have a calculator on me, so I'm not going to evaluate this entire expression. I'm just going to leave it on you. Okay? That is one thing. Now, that was honestly, I just wanted to teach you about intersection. That wasn't anything new for today's session. It was just that I forgot to tell you guys about intersection. So I just, pulled this up. That is just the probability notation that you should know. It's just an and, okay? I wrote probability, I meant probability. So now look, what are independent events? Now let's get back to today's lecture. I mean, I don't really think I need to explain what independent events actually are because the name gives it away. Independent events are events that are independent, right? Or in other words, let's say you've got a few events, right? You change the factors affecting a specific event, or you directly try to change or affect a specific event, and another event is not being harmed by it, it's not being changed by it in any way. It means both of the events are independent. I mean, there was nothing difficult in that, So, um, what do we have to learn about independent events other than the fact that they're independent? Because, I mean, that's an obvious thing. There's a formula to check whether two events are independent or not, right? And to know that formula, you had to know about the intersection thingy, which I just explained, right? This is how I remembered. Oh, I forgot to tell you guys about the intersection thing. So let's say you've got two events, event A and event B, right? These are two events. And you want to see whether they are independent or not. So you are going to use this formula. The probability the probability of event A plus the probability of event B should be equal. It should be equal to the probability of A intersection B, right? And if this equation is satisfied, if the probability of A plus the probability of B is equal to the probability of the intersection of A and B, then they are going to be independent. I'm going to write it over here, right? If satisfied, events are independent. Okay? Just give me a sec though. Uh, You know what? I'm sorry. That's a multiply sign over here. So if the probability of event A times the probability of event B, this entire, the product of both of the probabilities is equal to the intersection of both of the events, then both of the events are said to be independent. Otherwise, they are not independent, right? Because in some situations, let's say whether it's going to rain tomorrow or not, and whether I eat a pasta or I eat let's say spaghetti, right? Now look, both of these events are entirely different events. So through common sense, I can say that both of the events are independent. But in some situations, you might not know what the event actually is and how it's affecting other events, right? In that kind of a case, with the values given, you can just use this formula to figure it out for yourself whether both of the events are independent or not. Okay? Now look, if I was to give you an example for this, you know what? I don't really think I do need to give you an example. Let's just use these two. Look, I'm not going to create entirely new events. Let's just use this, okay? So, event A, let's see. No, look. Take a look at this. If I ask you, tell me whether event A and B are independent events or do they have an effect on each other. Okay? In that case, you're just going to see what is event A. You're going to find the probability of event A. You know what? Let's just do this. Event A is she picks up a red ball, right? We know she's picking. I didn't even write this. Dude, ignore that. That was a mistake. No, look. We are getting serious around here now. We know. No, look. We need to check whether these two events, event A and event B, are independent or not. How are we going to do it? Look, event A is what? Well, obviously, first we would have to find the individual probabilities for and the event A and B, right? No. Event A is that she is picking up two balls. It must have a red in it, right? So the two scenarios would be either, I'm so sorry. So either both of the balls are red, or just one of them is red, or just one of them is red. This is the probability of A, right? This is the individual probability of A. And that would be RR. I'm not saying this. I'm sorry. So either both of the balls she's going to pick up are going to be red. You know, either the first ball is red or the second ball is red, right? So we're going to find the probability for this. It would be 3 over 7 times 3 over 7, right? Plus 3 over 7 times 4 over 7 is equal to, oh, sorry, plus again 4 over 7 times 3 over 7. Now I know I'm lazy. I would have to grab myself a calculator. I don't exactly know where I put it though. Maybe inside but never mind. And then we're going to do the same thing with the individual probability of B, right? Now B says there must be one green, right? One green ball that she's going to pick up out of the two balls. So maybe both of them are green, or maybe the first one she picks up is green, or maybe the second one she picks up is green. And we ran out of scenarios. Now look, it would be 4 over 7 times 4 over 7 plus 4 over 7 times 3 over 7, or um, 3 over 7 times 4 over 7. Okay, now I'm going to pause the video just so that I can grab myself the calculator. Okay, now I do have a calculator on me, okay? No, look. So we have found both of the two individual probabilities, right? And the probability for A intersection B is, now I have to calculate that as well. I'm sorry. So 3 over 7 times 4 over 7, and everything multiplied by 2. It's going to be, dude, dude, give me a second. Now, oh no, oh no, oh no, 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 oh no, never mind. So the answer for this is 24 over 49. Now, if I write the formula once again, we get this. Probability of A times the probability of B is equal to the intersection of both of the probabilities. This should be 24 over 49, right? This thing should be equal to the product of the previous two probabilities. So it would be 33 over 49 times 40 over 49. Now, this must be equal to this. If that's not the case, then obviously that won't be the case. I mean, both of them are not going to be independent. The answer is 1320 divided by 2401. This entire thing is not equal to 24 over 49, which means both of the events are not independent. Now look, take a look at this. Let's look at it logically. If I put more red balls inside the bag, then obviously the total denominator, the total number of possibilities changes. Therefore, the probability for picking up a green ball changes as well, right? Or if I change the number of green balls in there, then the total denominator has been affected. Therefore, for the probability for picking up a single red ball also changes, right? Which means both of the events are not independent. But in order to prove them mathematically, we use the formula and we got ourselves the answer. This is a simple thing with the independent events, right? And you know what? Honestly, there are quite a few things remaining. There's the tree diagrams, okay? Then the simple tables, then the probability distribution table, and I do remember there were quite a few more things in here as far as I can remember. I think, yeah, so inshallah ta'ala from tomorrow onwards, we're going to focus on tree diagrams, okay? That's it for today. Assalamu alaikum wa rahmatullahi wa barakatuh.